This problem is about bond order. Please read the problem, make a plan to solve the problem, and then implement the plan. Let's compare our answers. So the molecule of interest is ClO bond. The first thing that we have to do is review the names of common polyanions so that we can draw the structure. Then we will use the Lewis structure of each resonance structure that is possible for this particular compound or an ion. Then we will calculate the formal charge to determine the most important resonance structure. And finally, we will determine the bond order from the number of bonds, double bonds or single bonds that are present in that structure. So the general structure or formula for perchlorate is ClO4-. The number of valence electrons is 7 for chlorine plus 6 times 4 for oxygen, and since it has a negative sign, means that it has an extra electron. So in total we have 32 electrons. When we have halides combined with oxygen, the halide is usually the central atom. That means that we are going to place chlorine bound to oxygen 4 times, and we are going to distribute the 32 electrons among these different bonds and lone pairs. We have 4 bonds, two electrons each, so we use 8 electrons for bonds. Left, we have 24 electrons. So one way to place 24 electrons consists of putting 6 electrons on each oxygen. Another way to do that is to have, let's repeat this structure or basic skeleton, is to have 2 electrons from one of the oxygens being shared with the chlorine atom. The other ones remain the same. Notice that in this particular case, chlorine has more than the 8 electrons of the predicted by the octet rule, which is possible because this is a large atom that can have an expanded valence number of electrons. This will be resonance structures, so we'll indicate the double arrow as a way to indicate that they are representative of the same polyion in this particular case. There is a third way to do this, which will consist of having not 1 double bond, but 2 double bonds. Again, the expanded valence electron capacity of chlorine makes this possible. And there is a third possibility, or a fourth possibility, in which we are going to have 3 double bonds. You may confirm that in each of these cases we still have the 24 electrons added after the first 4 single bonds. So the next step then is to determine what is the formal charge for the central atom chlorine in each of these particular structures. We are not going to be concerned about chlorine because all of them had exactly the same formal charge in the 4 resonant structures. So let's begin then by calculating the formal charge of chlorine for the first structure, which should be 7 minus the number of single pairs of electrons, which is 0, plus 4 shared electrons, which is plus 3. For the next structure, we have 7, again, no lone pair of electrons, plus 5, which is equal to plus 2. The next one is, again, balanced number of electrons of chlorine, 7, no lone pair of electrons, plus 6, which is equal to plus 1. And for the last one, we have 7, no lone pair of electrons, plus 1/2 of 14, which is 7, which is equal to a formal charge of 0. Now, if we think about the rules of formal charges, the one that is going to be most important is the one that has the lowest formal charge possible, which is structure number 4. So the next part will consist of using this structure to calculate the bond order. So bond order will require then to figure out how many electrons are being shared in bonds and how many bonds we have present. So double bonds, we have 3. So that's 6 bonds. And then single bonds, we have 1. And then we're going to have 4 atoms being bonded together. So this will give us 7 divided by 4, which is 1.75. The bond order for chlorate then is 1.75.